What is up, PreCalc? Here we have section 8.5, applications of matrices and determinants. Okay, in this section we're going to study Cramer's rule to solve a system of equations with matrices. Okay, and it's got a nice little shortcut for you. We're going to be able to use our calculator for some of this. You will, on the test, have to do a determinant of a 3x3 the long way, which we even kind of learned a little bit of a shortcut for that yesterday. And then we're going to solve a 3x3 with Cramer's rule, which is going to be more calculator. Okay? So all this math stuff in here, what it's saying is, if you take, so we have A1x, B1y, C1, A2x, B2y, C2, and you're going to turn that into like a 2x2 matrix. So if you do the determinant of the original coefficient matrix, and then you do the determinant of, you're going to replace the x coefficients with the answer one, and then you can divide those and you'll get x, the answer for x. And then you're going to do the determinant of this matrix, but with the answers taking the place of the y coefficients, and then you'll do that determinant divided by the original determinant, and that'll get you your answer for y. Okay? So your original determinant is going to be called just regular d. Okay? Determinant with the answers in the x column is going to be dx. Determinant with the answers moved to the y column is going to be dy. And then when we go to 3x3s, you'll have dz. And then you're just going to write those down and then go through and divide them. Dx divided by d, dy divided by d, and you'll get your answers kind of quickly. Just depends how fast you can type them in. Okay? So, hopping right into example 1, with 2x2s, we can probably do this just as efficiently with our brains. Okay? So we have 4, -2, 3, -5 times xy equals 10, 11. Okay, so we need the original determinant. 4, -2, 3, -5. And we'll have -20 minus -6. -20 minus negative is going to be +6, so this is going to be -14. Okay, now here's kind of the sneaky part. dx. You're going to take the answer column and replace that over top of the x column. So whatever like the subletter is, that's the column that the answers go over top of. So 10 and 11 are going over top of 4 and 3. And the y numbers are going to stay. So now we'll have -50 minus -22. So it's really +22. And we'll have a -28 there. And then we have dy. Okay, now the x's go back to normal. 4, 3. And the answer is going to go over the y column. We'll have 10, 11 over there. So now we'll have 44 minus 30. And that'll be +14. Okay, then to solve, x will equal dx over d. That was -28 over -14. So that's going to be a +2 for x. Y equals dy over d, 14 over -14. For -1. 2 comma negative 1. Okay, let you absorb that. Okay, you're going to need your original determinant of the coefficient matrix, dx, determinant of when you take the answer column and put it over the x column. And then dy, we change this one, so that is where people will go make a mistake, is that they'll forget to change the x's back to the originals when they go to the y one. Maybe not in a 2x2, because for 2x2 you might as well just write it down. That goes pretty quick by hand and brain power. But when we shift gears to a 3x3, and you change the x's, and then you forget to change it as you keep going. Alright. So 3x3, we got 4, negative 1, 1, 2, 2, 3, 5, negative 2, 6. There's your x, y, z. 12, 1, 22. Mr. Handke, can't we do the A inverse times B stuff from before? You could. You can do that to check it. But the point of this one is to use Kramer's rule. Okay? So we're going to do that. So first off, we need the original determinant. And we worked on determinant of a 3x3 yesterday by hand, the long way. And we did have a shortcut for it too. We shortened it up to just one row or one column. Today for this, we're just going to type it into the calculator and have the calculator tell us what the determinant is. If you do get a nice one, or you could probably do it by paper and pencil or brain power quicker, go for it. Okay, just a little refresher here with our calculator. There's matrix. We're going to go second x negative 1 to get to the matrix menu. I have a 3x3 already there. If you don't, you're going to go to edit. Let's just do matrix A. Make sure it's 3x3. Now we're going to type in our numbers. So we need 4, negative 1, 1, 2, 2, 3, 5, negative 2, 6. Okay, we got them typed into the calculator. Okay, now annoying part, you're going to have to quit. You have to exit the matrix menu, because if you do the next step from here, it's going to try to calculate the determinant of this matrix and then input it into that cell. So you have to get out, we have to quit, second quit, and then back to the matrix, second matrix, math. We're going to do some matrix math. We're going to do the determinant of second matrix A. And our determinant there is 55. Okay, dx. Now we just replace the answer column over the x column. So we'll have 12, 1, 22 there. And the rest of the numbers are the same. Negative 1, 1, 2, 3, negative 2, 6. So we're going to go back into the matrix. Second matrix. We're going to edit. And we're going to keep this the same. And now all I have to do is edit the left-hand side. 12, 1, 22. Okay. Everything else should match. Second quit. And now I can do second. I mean, it's not going to save you much time. You could do second enter to get the last thing, and it's going to bring up this determinant of A again. Or you could do what we did the first time. Second matrix math, second matrix A. 110. Okay, what I'm saying is you can do second enter, and that's going to bring up the last thing you typed, which was that, and then we can do it there too. So we have 110. dy. Okay, now we got to put the x's back to normal, and now the answers are going to go over the y column, and then the z's are there. So now when I edit my matrix, second matrix edit, I have to change the x's back. It's almost worth just typing them all back in just from scratch, because you're going to be changing two columns. 4, 12, 1, 2, 1, 3, 5, 22, 6. Second quit. Second enter. Negative 165. And then DZ. 4, negative 1, 12. Answer column there. We'll just fill in the rest of those before I make a mistake. 2, 2, 5, negative 2. Second matrix, edit. 3 by 3. And again, we're changing two columns, so we might as well just type them all. 2, 2, 1, 5, negative 2, 22. Second quit, second enter, 55. Okay, so we're going to have 110 over 55 for 2, negative 165 over 55 for negative 3, and 55 over 55 for 1. 2, negative 3, 1. Hooray! Okay, and the directions on the test will say use Kramer's rule. So you're going to have to show basically all of that. You're going to have all those written down, the answers to all that written down, and then the division written down. And if you want to check it with A inverse times B, go right ahead. Area of a triangle. Okay, area of a triangle plus or minus a half times the determinant of the matrix made by the x-coordinate, the y-coordinate, and then the third spot you just fill in with a 1, just to make it a square matrix for this to work. So x-coordinate, y-coordinate, 1. xy coordinate of the second point with a 1. xy coordinate of the third point with a 1. Okay? Sometimes the determinant comes out negative, then you're going to multiply it by a negative half so the area is positive. Sometimes the determinant comes out positive, then you're going to multiply by a positive half so the area stays positive. So we have plus or minus a half. I don't know which one I want to use yet. We'll find out. 1, 0, and then we put on a third 1. 2, 2 with a 1. 4, 3 with a 1. Okay, it wouldn't be crazy to use brain power here going across the top. That'd be a pretty easy one to do. Or going down the right-hand column. Okay. Or we could use our calculator. Second matrix, edit. 3 by 3. 1, 0, 1. 2, 2, 1. 4, 3, 1. Second quit. Still second enter is going to bring up determinant of A, but let's say you were doing some other math. Okay, second matrix, math, determinant, second matrix, A, and it's negative 3. So, I'm going to go with negative a half, because this was negative 3. We'll have positive 3 halves, or 1.5 square units. If it would have came out as a positive 3, we'd use a positive half. We're just trying to make it so the area comes out positive. Okay. Let's try, we can get through at least one more problem probably here. Testing for collinear points. So again, if all 3 points are collinear, if it's a small graph, you might be able to tell pretty easy by just plotting them. But the further things get spread out, the harder it is to eyeball it. Okay, so again, it's x1, y1 with a 1, x2, y2 with a 1, x3, y3 with a 1. And then, if the determinant is 0, they're all on a line. They're all on a straight line. If the determinant's not 0, then they're not on a straight line. Okay? So, I think you can do that. Make the matrix, type it in, do the determinant, and see if it equals 0. If it is a 0, they are collinear. If it's not 0, they're not collinear. And let's push pause and give that a try. Alright, so we should be getting a -6, which is not 0, so they are not collinear. That test for collinear points can be used for another thing. If you are given any 2 points on a rectangular coordinate system, you can find the equation of the line passing through those 2 points as follows. Okay? It's going to be by using our cofactors, minors and cofactors. Okay? So, if we had 0, 0, and 4, 5. Alright, you can see how they use x, y. So we're just going to leave that as x, y, 1. And then we'll have 0, 0 with a 1, and 4, 5 with a 1. Okay? They gave us 0, 0, so that's going to be pretty nice. We'll use that one, that row, because that's going to be 0 times C21, and we'll have 0 times C22, and only 1 times C23. So really the only one we have to do is 23. If you remember from your C's, we got plus, minus, plus, minus, plus, minus. That's going to be a negative. So we need the mini matrix determinant of 23. 23, so that's going to be x, y, 4, 5. And then it's a switch for that spot, so we're going to make it negative. So that's going to be x times 5 minus 4 times y. Equals 0, and then we'll push our negative through. Plus 4y equals 0. If you wanted to rearrange it, y equals 5x over 4. Okay? So we have x, y, then a 1, then your actual coordinates of the 2 points with a 1. One of them, hopefully they give you a problem where it's going to work out nice, where you don't need all 3 of these. You're just going to need one of them. And then you have to remember what spot it is in the cofactor table. Okay, this one was 23, so it was in the switch spot, so that's why we have the negative. Determinant, we had 5x minus 4y. We had the negative on the outside of it. And then that's going to help us with our equation. Perfect timing. There we go. We'll save the cryptogram for next time. All right, thanks for watching. Let me know if you have any questions.